Hey, you guys, happy Monday. I hope you guys had a nice weekend. So we're going to pick just right back up into it. We reviewed at the end of last week the beginning of this unit test, if you will, which was like the first stuff we learned. Quotient, reciprocal, and Pythagorean identities. No one sent me any questions or comments or issues that you may have had with that last review from Friday. Again, you can keep, that's okay. I hope that means everybody fully understood it. If not, just remember you can keep referencing it. You can also email me or text me through Remind. My goal for the end of this week is to try to have Google Classroom up and running so that I can get y'all to submit your assignments through Google Classroom. I think it'll just be easier for me to have everything in that location versus like checking my Remind and my email. But I haven't figured it out yet. And I got to watch some YouTube videos tonight, so, or in the morning, we'll see. So anywho, we are going to review Sum and Difference, which I feel like you guys did so great on when we did it. So I just am going to do one of each type of problem tonight. Well, it's night for me, but you'll be watching this tomorrow. And then I'm going to have you do 6 problems. Okay, so hopefully this shouldn't be too in-depth either. And by the end of this week, you guys, I guess Thursday-ish is when I have it planned that we'll take our quote-unquote test. The reason I say quote-unquote is because obviously it's not going to be traditional. I might not even have it in the same setting, like you might not even have to handwrite it. We'll see. I have not even figured that out yet, but I would think by Thursday, that's kind of my tentative plan, is to have the test on Thursday. Okay. Also, I like to grade and give you feedback, but I'm not putting anything into the grade book. All right. None of this is quote unquote required, but it is definitely important for us to keep on keeping on, if you will. And then we'll learn something new on Friday. Brand new for the new unit. All right, so let's start with Sum and Difference. Oh, let me start by saying either take a screenshot of this or print one out, or hopefully you have yours still from my class. You need it out. Remember, you need the unit circle for this. So I just took a screenshot, as you can tell, and just saved it onto this program I have. But you could just easily pull it up on your internet browser if you need to. Okay? All right, so I have another one handy, so I'm not going to keep flipping back and forth. I've previously worked these problems already. Okay, so with sine of 165, if you remember, the goal of this is we want to find 2 angles on the unit circle that will equal 165, okay? So remember that there's multiple correct ways to do this. So my first thought was this. But does everybody understand that is not the only right answer? You could also do this, for instance, okay? Or you could do subtraction if you wanted to as well. All right, I'm just going to stick with what I thought first. We're going to call this A, and we're going to call this B. All right, so hopefully you also have your flashcards handy. If not, you may want to get them. Your flashcards have the formulas on them. All righty. So the first thing is, sorry, my glasses are really dirty. Okay, so we want to write out the formula. So the formula goes sine of A, cosine of B, and then with sine, it's the same sign, so it'll be plus. So whatever this sign is, this sign will be the same. And then cosine A, sine B. All right, so we're going to go to our unit circle. We're going to go to 120 degrees. So that's here. Here. And we're going to take the sine, which is the y value. And that is root 3 over 2. Times the cosine of B, so we're going to go to 45 degrees, which is here. This is our x, so root 2 over 2. We're going to bring the plus sign down. Then cosine is our x value, which is negative 1/2. And then our sine of B is root 2 over 2. Okay, so we're like using the y value, the x value, and the y value. And then we put it all together. So we're going to have root 6. So remember, we can multiply the radicals because they're both radicals. Then here we're going to have negative root 2 over 4. A positive times a negative will give us a negative. Now, this obviously doesn't look like our final answer. The best final answer is to add our fractions, so keep the denominator, and then we want to just have the root 2 being negative. Okay, so plus a minus is not really the best way to leave that. Plus a minus is really the same as a negative. So here's your final answer. Okay. All right, so let's do the next one. So cosine of negative 195. There are multiple ways to go about this. This is the way that I thought about it when I worked this problem. Or you could do, 120 minus 315, anything like that. It really does have to be a minus, though, because we're trying to get a negative. Remember, you want your angles to be positive, but you want to be subtracting, okay? We never want to have like a negative angle in there. That's a no-no. All right, so we want to always be working with our positive angles and just subtract. All right, so this is our A, this is our B, so let's remember the formula. So it goes cosine, cosine, so cosine of A, cosine of B. Then it's the opposite. So because this is a minus sign, this is going to be a plus sign. And then sine of A, sine of B. That's really the only thing that y'all have messed up on in the past, is just being really careful about those signs. Okay, so now we're going to go to 30 degrees, which is here. And what was the other one? 225. So we're going to go here. We got some negatives in there, so let's be careful for that. All right, so the cosine at 30 degrees is root 3 over 2. And the cosine at 225 was root 2 over 2. And then the sine, the y value at 30 degrees was 1/2. And then negative root 2 over 2. And then I think y'all will remember from here, a lot of you just went to the final answer. You know it's going to have a common denominator of 4 when we go straight across here. So let's just go ahead and put them together. And then a positive times a negative is a negative. And then a positive times a negative is also a negative. And do y'all remember, like, the answers should look the same every time? The only thing that will differ are the signs. So like this first problem up here, the root 6 was positive, the root 2 is negative. And in this problem, the second example, they're both negative. Okay, but nonetheless, the answers look the same. Okay, tangent was a little bit of a daunting one at first. Y'all were like, oh, this is awful. But you got the hang of it pretty quickly. You should kind of already think of what the answer should look like. Okay, the second thing is, this is in radians. So we need to be thinking in radians, and I'm going to go back here and do a little review with you. When we did this in class, we talked about, like, you could go around and convert every single one of them if you wanted to, but that takes a lot of time. So if you just remember, it starts at 2. And then, so like, really, you could add this 15 degrees in. That would be your 1. And then you add 1 here. That's 5, 6, 7. So this is 8. Or if you remember, Bailey made the observation that it just skips 4. So then it goes 8, 9, 10. If you skip 4, then it goes 14, 15, 16. Skip 4, 20, 21, 22. And then, of course, this is like pi over 12. Okay, I'm just being a little, like, I'm just trying to be a little lazy here to get through it. Okay. And now that I've started, I can't stop. So I'm going to finish this out, and then we'll go back to the problem. So if we do this little bit of front loading, meaning do a little bit of work at the beginning, it makes everything a lot simpler when we do the radian problems. Okay, and you could even take a screenshot of it now if you wanted to, and that would make sense to kind of use that as we go. All right, so now we're trying to get a -5. So in my head, I'm just thinking, how do I get a +5? And then I just switch the order. Okay, so I know like 8 minus 3 is 5, and 9 minus 4 is 5. And I could use either of those. Oh, let me go back. With tangent, let's make a little reminder to ourselves. Do you remember there's some we want to avoid? It's the ones at the x-axis. So here... well, I guess I should include all of that, the 30 as well. So we want to exclude these, and these. Because if you do the tangent of them, it's √3/3. And that's just, it makes it like pretty complicated, if you will. And so we don't want to use those, okay? So if you avoid those 4 angles, it'll just make a lot more sense. Well, it'll make your life a lot easier. Okay, so like in this problem, we would not want to use 10, or we would not want to use 14, etc. Okay, all right, so let's work this problem. I'm going to use pink since it's it needs to kind of stand out from the rest. All right, since I've worked this one already, this is what I've came up with. That equals this over here. Now, if you get it wrong, a lot of times what happens is you just will get a +5. Like some of you on accident might have these reversed, and that will cause you to have the incorrect answer, just FYI. Okay? All right, I don't know if y'all remember this. I think you probably will. I would come up here and I would write what the tangent of those angles are, just to like go ahead and have it written down. So at 3 pi, that's here at 45 degrees. If I did the tangent, which would be like the y divided by the x, what would I get? I would get 1. So I'm just going to put a 1 here. And then over here at 8 pi, if I did the √3/2 over -1/2, I would get a -√3. Okay, so I'm going to put that here. All right, let's fill in the formula now. So it goes tangent of A, and then it does the same sign as what's here, and then tangent of B over 1 minus tangent of A times, oh wait, I said minus. It needs to be plus, it's the opposite of the sign, tangent of A, tangent of B. Okay? All right, so let's fill it in. This is our A, and this is our B. So we are going to have 1 minus a -√3. Already, you might want to pause and make sure you understand. There's a minus because it's the same sign as the problem, and there's a minus because our B is a negative. Okay? Then 1 plus, and then take the ones that are in black up here and multiply them. So 1 times -√3. All right. Uh-oh, battery's low. All right, so now let's simplify. So we're going to have 1 plus √3 because of the double negative here. All right, and then we'll have 1 plus a -√3, because do y'all understand? A 1 times a √3 is going to give us a -√3. Okay, now I don't want to leave it like that, so I'm going to go back and fix it. 1 plus a negative is really 1 minus √3. Okay, then at this point, you are responsible for doing the conjugate, because you can't let this √3 live in the denominator. All right, so the way that we do that is we do the same as the denominator, look exactly the same, but change the sign. And then we FOIL. Okay, so I'm going to go ... keep going. All right, so then we're going to FOIL. So we're going to go like this. Let me get pink again. Well, black might be good. All right, so 1 times 1 is 1. 1 times √3 is √3. √3 times 1 is √3. And a √3 times a √3 is plain 3. Okay? Because it would be √9, which the square root of 9 is 3. On the denominator, I'm going to do the same thing. 1 plus √3 minus root 3 minus 3. Okay, and then we're going to simplify. So this 1 and this 3 can add together. And then these two can add together. You add the coefficients out front and keep the radicals. So there's an imaginary 1 here, imaginary 1 there. And then these on the denominator are going to cross out. And then you're left with a 1 and a minus 3. And it should give you that every single time. Okay, you should get negative 2 in the denominator. All right, here's where some of us made careless mistakes on the quiz. You have to divide this negative 2 into both of the terms in the numerator. So the 4 is positive and the 2 root 3 is positive. You guys, when I divide a negative into both of them, they will become negative, okay? Because a positive divided by a negative is a negative. And then the 2's are going to cross out because 2 divided by 2 is 1. Okay? So there's an imaginary 1 here. It's just not necessary. Now, I went step by step. Some of y'all are probably like, I remember that. But just in case you have forgotten, that's why I went through step by step in that problem. And so with tangent, every single answer should look like a 2 and a root 3. Every single time. Okay, so I went pretty extensively. So we can have positive angles, we can have negative angles in degrees, and then we can have positive and negative angles in radians. All right, but basically it all boils down to the unit circle, making sure we have this. Yeah, so here are your 6 problems that I want you to do. Now, when you turn these into me, if I can get Google Classroom working, you can do it there, but I probably won't by in the morning. So you can just text them or send them to email. I have listed out all of the choices, okay? So I hope y'all are familiar, like A through D. These will be sine and cosine. And then E through H will be tangent problems, okay? So all you need to do for me is you just need to tell me, I probably shouldn't have put that line in there. I should just go like this. All right, so all you need to tell me is like number 1 is A, number 2 is C, number 3 is D, etc. Okay, and that way, now if you want to show me your work, you certainly can, or if you want to just see if you have them right first, and then I can give you the feedback. If you can't find your mistake, these are ones where a lot of y'all really needed me to say, like, here's where you made your mistake. Then you could, of course, take a picture of your work and show it to me. Okay, so try those 6. Do the best that you can, and we'll continue reviewing, kind of putting it all together starting tomorrow. All right, I hope y'all have a great rest of the day.